Video, we are going to be learning about carboxylic acids and esters. Carboxylic acids have this functional group. So a carbonyl connected to a hydroxyl. Obviously, you know that lone pairs are here. Sometimes they'll represent it as this, and sometimes you might see it as this. But all of these are the carboxylic acid functional group. So this is the carboxylic acid functional group. We'll write that down. Carboxylic acid. So all carboxylic acids have this functional group. So if you're doing it expanded, it's going to look like this. If you're looking at an ester is between two carbons, okay? The carboxylic acid could have a hydrogen here, but it also could have a whole bunch of carbons. The ester, on the other hand, is sort of like the ketones and the ethers. Remember how they were always in the middle? So are esters. Carboxylic acids are always at the end, the way aldehydes are. This is an ester. So you see what they have in common is the carbonyl O. The big difference is that carboxylic acids have a hydrogen on this O, and esters have these carbons on either side. And they can be isomers. So just like alcohols and ethers are isomers of each other, aldehydes and ketones are isomers of each other, carboxylic acids and esters, they're going to have, if they have the same molecular formula, you can have isomers. Okay? All right, let's start off by learning how to name carboxylic acids. We're going to learn some common names, and we're going to learn some IUPAC names. Let me give you a few common names right now. They're similar to the aldehyde nomenclature, except instead of saying, formaldehyde, you're going to say formic acid. Remember, form meant one carbon. So formic acid is a one-carbon carboxylic acid. This is formic acid. Acetic acid, which vinegar is just dilute acetic acid, is a two-carbon carboxylic acid. Okay. Propionic acid is a three-carbon carboxylic acid. Put it CH2, CH3, and then butyric acid is a four-carbon carboxylic acid. Okay, those are common names. 5-carbon would be valeric acid. You're going to notice in your reading, you're going to see lots and lots of common names. We switch over to common names when we do biochemistry, but right now, I don't want to overwhelm you with common names in addition to IUPAC. So if you know these four, it's good enough for common. And then if you see other common names in your homework, no big deal. Just look it up and you'll be fine. Let's switch over now to IUPAC names. Oh, one other common name I wanted to show you for a dicarboxylic acid. Dicarboxylic acid, meaning it has two carboxyl groups. This guy over here. This is called oxalic acid. Okay. If you take a higher level chem, we do the oxalate polyatomic ion. It's got this goes and this goes. It's a -2. Anyway, we'll talk about the charges a little later on. Right now, let's talk about IUPAC naming of carboxylic acids. What you're going to do is you're going to write down the alkane name, drop the E, and replace it with oic acid. So if it's methane, it becomes methanoic acid, dropping the E. If it's butane, it becomes butanoic acid, dropping that E. So let's say I had this one over here. This is always going to be carbon number 1. Okay, so this is 1, 2, 3, 4, 5. Guess what the name will be? Remember, 5 carbons would be pentane. You drop the E, This would be pentanoic acid. And you don't tell me where the carboxylic acid functional group is. It's always carbon number 1. Just like with aldehydes, you don't have to tell me it's 1-pentanal. In fact, it's wrong to do that. You just write pentanal. This you would just write pentanoic acid. Now, carboxylic acids are the highest in priority. So if you have an alcohol in there with the carboxylic acid, the alcohol is a hydroxy group. If you have an ketone in there, the ketone is an oxo group. If you have an aldehyde there, the aldehyde is an oxo group. So all the others act as substituents. The parent is going to be named after the carboxylic acid because it has higher priority. So let me give you a scenario that's got a whole bunch of different substituents here. So I have the carboxylic acid over here. So this is carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know it's nonanoic acid. Nonane, drop the E and put in an oic acid. Now let's put some substituents. Let's say I have an OH here. So this is a hydroxy group. Let's say I have a methyl here. Let's say I have a bromo here. Bromo. And let's say I have a ketone group here. All sorts of fun stuff. All right, so now you name these guys as substituents. This is a bromo, this is a hydroxy, this is a methyl, and this is an oxo. So aldehydes and ketones, if they are in the middle of a carboxylic acid, they're named as oxos. So, get this a little closer here. Now we need to alphabetize. Bromo, hydroxy, methyl, oxo. So we're going to write 3-bromo, 4-hydroxy. We're alphabetizing. It's not by the numbers, it's by the first letter, B before H. 3-bromo, 4-hydroxy, 6-methyl, 8-oxo, and then I'm going to continue it here, nonanoic acid. So the O is connected to the N here. That's what this molecule would be called. Okay? Good. There are dicarboxylic acids. So I put an OH over here. Okay, so what would this be called? Let's put the hydrogens. So this would be butane dioic acid. So you don't have to drop the E here, and you just write dioic acid instead of ic acid. Okay, now there's this method of that they use to identify substituents in the common names. If you have an alpha carbon is the carbon next to the carboxyl functional group. We're going to be talking about alpha amino acids later on in the semester, and that just means that there's an amine group hooked up to the alpha carbon. What is the alpha carbon? It's the carbon that's right next to the carboxyl group. So let's say you have this carboxyl group here, and I'll just do this structural drawing like this, skeleton, and this right here, this is called the alpha carbon. This right here, this is called the beta carbon. And this right here, this is called the gamma carbon. So this is alpha, beta, gamma. So in common nomenclature, and you only use alpha, beta, gamma with common nomenclature. In common nomenclature, if you have, for example, a hydroxy group on carbon, on this carbon here, or you have it on this carbon here. Then you tell everybody, oh, the hydroxy group is on the beta carbon or it's on the gamma carbon. So let's say I put it right here. This would be on the alpha carbon. So the name of this would be alpha hydroxy butyric acid. Alpha hydroxy butyric acid. Now for IUPAC naming, if you have a hydroxy group on this carbon, this would be 2-hydroxy butanoic acid. So alpha hydroxy butyric acid is the common name. And like I said, you only use alpha, beta, gamma with common names. The IUPAC name would be 2-hydroxy butanoic, sorry, I'm curving it here, acid. Okay, good. We'll talk more about properties and all sorts of other stuff in the next video.